Our topic today is motion on inclined plane. When a body is on an inclined plane, how can we determine its acceleration and the frictional force that is acting on that body? So this is an inclined plane, a slopy plane that makes angle theta with the horizontal. If you now have a body on this plane, let's call the body A, and we have the normal reaction. From our last video, we were able to determine the force that is perpendicular with the plane and the force that is parallel with the plane. So we have to fix it now. We have, this is mg cos theta. We have normal reaction here. Then the force that tends to drag the body down the plane is mg sin theta. Then when the body is at equilibrium, frictional force will hold the body or prevents the body from sliding down. Then the weight of the body will be radically downward. So we're able to determine this in our last video. Now we want to calculate the acceleration of the body when the body is in upward motion and when the body is in downward motion. Before we proceed, let's quickly look at when the body is not moving. That is when the body A is at rest. We have at equilibrium, that is when the body is not moving. At equilibrium, the frictional force is equal to mg sin theta, and the normal reaction is equal to mg cos theta. So we're able to determine this in our last video. Then from here we can bring our coefficient of static friction, which is frictional force over normal reaction. We now have sine or mg sin theta over mg cos theta. The mass and gravity will cancel each other. Then we now have the coefficient of static friction over equals to sin theta over cos theta, which is tan theta. So we're able to determine this in our last tutorial. Now this is what happens when this body A is at equilibrium, where the mass is the mass of the body that's on the plane. Now I want to look at it when this body is in upward motion, when it is moving up. Now I want to look at when this body is moving up the plane, or when the applied force tends to move the body up the plane. Then when we have that, the applied force is going to be here. This is the applied force. The applied force. This is applied force. Applied force. Then if the direction of the motion is up the plane, it means from the definition of frictional force, the frictional force will oppose the movement. That means we are having the frictional force here. Now it means that the total force that's acting downward is mg sin theta and the frictional force. By the time we now calculate the resultant force, we now see that the applied force is always greater than the frictional force. So we now have F, which is the applied force, minus the total force that we have acting downward, trying to oppose the movement, is mg sin theta plus the frictional force, which is equal to the net force or the resultant force. Then if you remove this bracket, we have F minus mg sin theta minus frictional force is equal to mass times acceleration. This is equation, I'll call it equation 1. Let's see, we can make the acceleration subject to the formula. That will give us applied force minus mg sine theta minus frictional force over the mass of the body. So this is the acceleration of that body. Then where F is the applied force, then this is the frictional force, and this and the mass of the body. If the coefficient of static friction is not equal to 0, we have that frictional force is equal to the coefficient of static friction times the normal reaction. Then we can substitute the frictional force in equation 1, which is A equals F minus mg sine theta minus, instead of writing frictional force, we can change it to coefficient of static friction multiplied by normal reaction divided by mass of the body. So we can call this equation 2. This is equation 2. With these two equations can be used to determine the acceleration of the body when the motion of the body is upward. Equation 1 tells us when the coefficient of static friction is not given, then you have the frictional force. While equation 2, if the coefficient of static friction is given, we can determine the normal reaction. From when the body is at equilibrium, we can determine the normal reaction, then substitute into equation 2. Then we calculate the mass and the acceleration of the body. Let's look at when the force is applied, which tends to move the body down the plane. Now, if the acceleration is downward, it means that we have the applied force. This is the applied force, and according to the definition of frictional force will oppose the movement. So this, we are having frictional force here, frictional force. Then this is applied force, applied force. So if the body is moving downward, it shows that the total force that we have that tends to pull this body A down the plane is F and mg sine theta, which means that it shows if the direction is here, this force acting here is greater than the frictional force. So it means that the total force that we have is available to overcome the frictional force. So we have F, the applied force, plus mg sine theta minus the frictional force is going to give us the resultant force. So we have F plus mg sine theta minus frictional force equals to mass times acceleration. This is equation 3. We can make A, the acceleration, subject to the formula. That will be F plus mg sine theta minus the frictional force over mass of the body. So this is acceleration of the body if the acceleration is moving down the plane. Let's substitute the frictional force when the coefficient of static friction is not equal to 0. So we have frictional force is equal to coefficient of static friction multiplied by the normal reaction. So in substituting the normal reaction into this equation, this will give us acceleration equals applied force plus mj sine theta minus coefficient of static friction multiplied by normal reaction. Everything divided by the mass of the body. So this will give us equation 4. This is equation 4. Equations 3 and 4. We can use the two equations to calculate the acceleration of the body when the motion is downward. Also, we can decide to make the frictional force subject of the formula. We can also determine the frictional force, as the case may be, say from the same equation. Now, when the force is upward, or when the applied force is upward, it tends to move the body up the plane. Equation 1 and equation 2 can also be used to determine its acceleration. Likewise, we can also make the frictional force subject of the formula if we want to calculate the frictional force. So these are the equations that we can use to determine the acceleration of a body when we are having a body on an inclined plane. When the force is applied, it tends to move it up the plane or tends to move it down the plane. At equilibrium, when the body is at equilibrium, we can have this set of equations. From there, we can determine our coefficient of static friction.